are from group number 9. We will be discussing about article number 1, which is the title is Colorimetric paper bioassay by horseradish peroxide for the detection of catechol and also resorcinol in aqueous sample. For the introduction, we have two molecules, which is catechol and also resorcinol. These two molecules will cause pollution, especially water pollution in the river. Catechol is classified as a possible carcinogenic to human, and resorcinol can cause serious impact to the wildlife. So for detecting the pollution, we use paper-based biosensor. Because of its property to break the liquid by the capillary reaction, it is inexpensive, sensitive, user-friendly, rapid, and do not require power source and can be easily delivered. Because of this advantage, the paper-based biosensor can be provided and efficient for the environmental monitoring. However, the specific response of this sensor to the pollutant like catechol and also resorcinol in real-time water sample is not yet been widely reported.
Hi, so let's continue to the significance of this study. The first significance of this study is using horseradish peroxidase to identify phenolic substance like catechol and resorcinol in aqueous samples. Next is to immobilize an enzyme on paper using chitosan entrapment and glutaraldehyde cross-linking for a quick and effective technique. Then to regulate the concentration and amount of the enzyme used in the biosensor's construction. The mixing of all the components in chitosan and deposition on the paper instead of layer by layer deposition is easy and time-saving.
Okay, so for next part is the application of the biosensor construction. So we found from this paper that this biosensor is used for environmental monitoring, which specifically for detection of phenolic compounds in wastewater. And this biosensor will utilize horseradish peroxidase, which is HRP, and catalyze the oxidation of benzenidiol to benzosemiquinone, which reacts with chromogen called 3-methyl-2-benzothiazolinone hydrazone or MBTH, and it will produce a colorimetric response depending on the phenolic compound and its concentration.
I will be continuing with the working principle. The main product is a paper-based biosensor used to detect catechol and also resorcinol. So the main principle behind this bioreactor is to immobilize the HRP enzyme onto a paper using immobilization method. So the paper used is the Wattman#1 filter paper, and the enzyme is the horseradish peroxidase, which will be immobilized onto the filter paper, which is 1 cm by 1 cm big. And upon immobilizing, a colorimetric assay will be conducted, whereby images for the immobilization enzyme is based on color intensity, which will be used and produced by ImageJ software. As for the immobilization method, there are three methods. The first one is physical absorption. For this absorption, the bonds are involved van der Waals, hydrophobic and hydrophilic interaction, and also electrostatic interactions. These are all weak bonds which will easily disrupt during the washing step, and enzyme will be de-immobilized. Secondly is covalent coupling. So covalent coupling is done by unmodified paper and also chitosan based paper. As the results shown below, chitosan paper is much more better compared to the unmodified paper. This is due to the lysine residue presence in the chitosan paper. Thirdly is the entrapment method, which is done by the chitosan polymer. This method is the most effective among the other two immobilization methods because it contains cross-linking fibers, which results to high retention of the enzyme onto the paper. Passing over to the next person.
For the alternative solutions, there are the needs to optimize the effective of biosensor construction. There are 4 factors need to be considered to make the effective biosensor using the horseradish peroxidase. First is determination of optimum hydrogen peroxide concentration. Hydrogen peroxide concentration needs to be fixed because excess amount of hydrogen peroxide will reduce the enzyme activity. 30 millimolar of hydrogen peroxide was the safe for catechol. Second is determination of optimum MBTH concentration. Higher MBTH give bluish color on reaction with horseradish peroxidase. 50 millimolar of MBTH give the best result for 45 millimolar of catechol. Determination of optimum pH. The optimal pH show at the range between 6 until 6.5. Increase the pH will increase the color intensity. The biosensor fabricated with all the optimized components and pH has to check for the visually detectable lowest concentration. The biosensor gives faint pink to red color for catechol with a visible LOD of 50 mg per liter or 0.45 millimole.
For summary, paper-based biosensor developed using Horadish peroxide for detection of phenolic compound. The immobilized method to detect these two compounds using chitosan entrapment with glutarildehyde cross-linking. That's all from us. Thank you.